Good morning, students. Welcome to our first class. You have energy to listen to my class? Of course, right? You have the energy. Do you have the energy to pluck a flower from your garden? Yes, you have. Do you have an energy to dance on the floor? Yes, you can. Right? So all the performance what we have to do is based on our energy. Right? We need an energy to do work, to do any activity. So the energy is very important. And sources where we are getting energy is also different. We get energy in various forms around it. Right? From food, from exercise, from swimming, from any activity that we are doing will give us an energy. So, shall we define energy in the way of physics? Sure, we can. Energy means it is the capacity to do work. Or energy of a body is its capacity for doing work. That means all body have a capacity, right? If they are utilizing this capacity for doing or performing work, then we can call it is energy. You got the idea? It is the capacity for doing work which is known as the energy. This energy is measured same unit as that of the work. And do you remember what is that unit of work? Yes, it is the joule. So energy is also measured in terms of joule. And see, this energy is existing in our world in different kinds of form. In the universe itself, it's stored or exists as mechanical energy, heat energy, light energy, electrical energy, like that. But today we need only two types of energy to discuss, and mainly in this video we will discuss about kinetic energy. That means another form of a mechanical energy. Actually, this mechanical energy has two distinct forms. One is potential energy, another one is kinetic energy. So here we are discussing about kinetic energy. We have said energy is the capacity for doing work, and how it is become in terms of a kinetic energy. The word kinetic means moving, right? Something has to move. And if it is moving, then we can say that that body possesses kinetic energy. It's so very simple, right? So energy possessed by a body due to its motion is called kinetic energy. So we are writing kinetic energy as Ke. K stands for kinetic, E stands for the energy. So we can clearly say that or we can clearly define kinetic energy as energy possessed by the body by virtue of its motion. Energy possessed by a body by virtue of its motion. Think, there is a bicycle is moving. This is one bicycle and it is moving. If it is moving, we can say that the bicycle have a kinetic energy. And you have seen athletes are running in our tracks. See, this is one athlete and he is supposed to running. He is running on the track. So we can say that he is moving. So there is a kinetic energy. And you can see the coins in the carom board. When you're striking the coins, they will move in that border, right? So we can say that we are imparting kinetic energy. So all over, kinetic energy means it is the energy possessed by each body by virtue of its motion. Energy possessed by its motion. Energy is due to its motion. That energy is known as the kinetic energy. It's very interesting one, right? So you can say whatever the things which are moving around you have a kinetic energy. Let's write how we can express kinetic energy. How we can express the kinetic energy, or how we can find out kinetic energy of a body. For that, we are considering a situation where one body is moving. See, this is a body and it's moving. So the body have a mass m. Since it is a moving, it has a velocity v. And also the body has a displacement, right? When it is moving, it have a displacement. And all this process is happening under constant acceleration. Under constant acceleration. That means you can consider here is a body of a mass m moving with the velocity v. When we have to define the kinetic energy of this body, work done by a force in increasing the velocity of this body from its initial state to the final state, right? That means the body was at rest when it was for the first time. So we can say the initial velocity is 0. And after we are applying force, the body moves and reaches a particular point with a certain velocity, final velocity v. So here we have given work to increase the velocities from 0 to v. So let's say A be the constant acceleration produced and S be the displacement in the direction of the force happened. So you got the idea, right? Or what we are going to do, we are formulating the kinetic energy. That means how we can express kinetic energy. How we can find out the kinetic energy. That's we are discussing now. Since it is in a constant acceleration, we can write down the equation formula that v square is equal to u square plus 2as. V square is equal to u square plus 2as. Where v stand for the final velocity, u stand for the initial velocity, a is the acceleration, s is the displacement. In this case, here velocity, that means our initial velocity is 0, right? So we can write down this equation as v square equal to 0 plus 2as. V square is equal to 0 plus 2as. From this, you can write acceleration as v square by 2s. right? By rearranging this equation, you have the equation acceleration is equal to v square by 2s. So you keep this equation in your mind because I am going to rub the board. So here we have an equation for acceleration. Acceleration as a is equal to v square by 2s. And here we know that we have given force to this body, and that is causes the kinetic energy, right? So we can represent force in this activity as m into a, right? By Newton's second law. So here what you do, substitute for this acceleration, m into v square by 2s. Substitute for that acceleration here. What you got? You got an expression. You got an expression m v square by 2s. What does this stand for? It is a force, right? The force applied in this equation is F equal to mv square by 2s. So, if you got the force, how you can represent the work done in this case? Work done in this case, how you can represent the work done? Work done is a product of force and displacement, right? Work done means it is a product of force and displacement. Now substitute it for the force equation here. We have force equation mv square by 2s into s. Okay, mv square by 2s into s. Then you can cancel out these two equations. Here you have the work, and equation is right as mv square by 2. mv square by 2 or half mv square. So that is the work done on the body, and it is stored as kinetic energy. Okay, so this is the work done. W is equal to half mv square is the work done on the body, and it will be stored in it as a kinetic energy. So you got the expression for the kinetic energy as kinetic energy is equal to half mv square. So this is very simplest formula that you can study in a physics, and you can apply in it too. So it is so easy for you, right? Kinetic energy is equal to half mv square. And how we have come to this equation? We are considering a rolling body, and that rolling body we have applied a force. That force is kept into rolling, and from that we have find out equations for we have find out the kinematic equations, then equation for the acceleration, then equation for the force, and we have find out what is the work done in that process, right? Then we got the equation W is equal to half mv square. That is the energy stored in that body as a kinetic energy. So here it is. Now your kinetic energy is very simple in your hand. Study well. Thank you.